Hi everyone, in this video, we will see how potentiometry is applied in electrochemistry. What is potentiometry? Potentiometry is a technique used to measure potential of an electrochemical cell at zero current. Functions of potentiometry. It is used to locate endpoints of titrations. It's also used to measure ion concentration directly from the potential of ion-selective membrane electrodes. By using ion-selective membrane electrodes, the advantage is that the electrodes are free from interference. Besides, they provide rapid, convenient and non-destructive methods of determining anions and cations quantitatively. For example of an ion-selective electrode is pH electrode.
Let's start with the principle of potentiometric analysis. For a complete cell, it consists of an indicator electrode that responds to the analyte, and a reference electrode of fixed potential. The potential difference is measured between these two electrodes. Cathode acts as the sensing electrode, while anode acts as the reference electrode.
Cell potential is equal to the potential of the indicator electrode, minus the potential of the reference electrode, and liquid junction potential. Based on the equation, cell potential depends on the potential of the indicator electrode, because the potential of the indicator electrode is related to the activity, or concentration of the analyte. Meanwhile, the potential at the reference electrode, and the salt bridge are constant.
In potentiometry, it implements the concept of a galvanic cell. In the cell, it uses indicator and reference electrodes to measure voltages that provide chemical information.
Cell and electrodes. The reference electrode can be either silver chloride electrode, or saturated calomel electrode. Liquid junction potential may occur during the potentiometric measurements, due to unequal mobilities of ions. For indicator electrodes, it can be either metal electrode, or ion-selective electrode. Metal electrodes develop an electric potential in response to a redox reaction at the metal surface. Meanwhile, ion-selective electrodes selectively bind one type of ion to a membrane to generate an electric potential, and does not involve a redox process.
A pH electrode is one of the example of ion-selective electrode. The pH measurement involves a glass electrode which selectively binds with hydrogen ions. The membrane consists of two surfaces of glass as well as they absorb water. What happens to the glass membranes? Hydrogen ions will diffuse into glass membranes and replace sodium ions in the hydrated gel region. The ion exchange is in equilibrium. Charge is slowly carried by migration of sodium ions across the glass membrane. Measured voltage is correlated with a pH, which is then used to measure an unknown concentration of analyte. Before using the pH electrode, it should be calibrated with 2 or more standard buffers before use. Parameters of ion-selective electrodes. There are 4 parameters for ion-selective electrodes, which are selectivity, sensitivity, limit of detection and response time. Ion-selective electrode has higher selectivity. The selectivity of the electrode is determined by the composition of the membrane. The membrane will allow the uptake of only one specific ion into it. The interface between membrane and solution will undergo either ion exchange process or ion transport process, which result in the potential developed. Next parameter is sensitivity. Ion-selective electrode has the ability to detect primary ions at lower concentration. For the detection limit, ion-selective electrodes can determine the lowest concentration of a substance that can be distinguished from the blank solution. Lastly, for the response time, it is time taken to reach a value of within 1 mV of the equilibrium value. It usually increases with decreasing determinant concentration. Thank you for watching.